Okay, I'm gonna do the screen record thing. Okay, so again, what is your earliest memory? List the details that you can remember about it. How old were you, and how long ago did the memory occur, given your age? What is the overall feeling of that memory? So, does anybody want to share? I'm gonna put the mic. I still have a broken microphone. Does anybody want to share with us their memory? Yeah.
So my earliest memory is I was in preschool. I used to do like music lessons after school. It was just like another way to get to see them all. And at one point, I did realize I would like to play with the class. I would sit down, I would sit attention, I would do everything. At one point, with my mom and dad, I threw Spider-Man around at the teacher. Missed it. But still, it was a weird memory. It's weird to think about it. How much I can do actually did that. But it was comforting. And through the car while I was here, once I was here from 16 to 18 years ago. But it's a weird feeling to look back and remember.
I remember like being able to do that now, but it was like
I was young back in the day.
do you still play drums?
I did actually.
Cool. It's nice that you remember that you even acquired those memories before I played them. My earliest memory was when I was 4, my sister was 2, and she was like learning how to talk about her, and she couldn't pronounce Olivia, so she would say Olivia, and that would piss me off to beyond belief. I was like, that's not my name. If you can't say it, don't say it. And everyone else thought it was like this would just like, oh, she's crazy. I was like, this is so annoying. She learned, but like, looking back on it, I was like, oh, it's actually real, it's fine, right? But in the moment, I knew that. And how long ago was that? Like 15 years ago. Yeah, seems very long. Mine is from when I was before, like, so I was and stuff, and me and my friend had this big party, and like the lady told us that she was going to do like a picnic table, and we were driving to shop, and she was like, draw on the picnic table, and so as soon as she left, we were like, we're going to go draw on the picnic table. So we like drew all over it and talked, and she was so mad at us, and we had to talk about like the rest of the day. My mom was like so mad when she came to pick me up. She's like, why would you do like I don't know. All these things seem like a good idea at the time, right? Probably like it wasn't before I was probably like 19 years old. So it seems like you all have this description of those memories as kind of like a chain of events. So we'll talk about this a little bit. Like there's a difference between remembering facts and remembering the sequence of events. Like that mental time travel, like you're teleporting back to that time when you remember those feelings. Sort of associated. Oh, sure. I just wanted to say that for me, like I've had this question a lot in the past, and it's always hard for me to answer because whenever like when I was little, I seem like everywhere I went, my parents had a video camera. So like I don't know if it's something like I actually remember, or if it's just something I've seen replayed to me. That's a great point to bring up. We're not going to talk about it in this class so much, but there's this concept of false memory, where you remember remembering something, but that event never actually occurred. Somehow got into your brain and it's part of your string of like conscious remembering of the past, but it's not actually true, which is a really interesting phenomenon. I hope you guys continue studying psychology and maybe take a look at the concept of false memories.
It's really interesting because where I work, it's a real big app. When we are counseling or doing with certain clients, the majority of them, maybe 8 out of 10, when you think about the certain memories they think they have, they don't. And a lot of times they tell you something that never really occurred. It just seems we don't really approach it like this because it's not usually but I see it happening all the time. So we think the moment I see if your memory's accurate, and taking it back through time, if you will, where you realize it probably never really occurred. But I don't know why it's the majority of it. You try to claim yourself or whatnot. It's the majority of it.
Well,
In my experience,
everybody actually has false memories, right? When we can show in labs that everybody has the capacity to form false memories.
something with drugs and studying brains and respiratory things that was a really interesting
Um, I've also heard at events, we actually have people that I know go through similar things in that there was a practice in clinical psychology of hypnotizing people and having them remember these past traumatic events that were repressed. But there's actually a lot of evidence that that process of hypnotizing and remembering past events creates false memories. So there were a good amount of people who had false memories of horrible things like being molested or threatened in various ways that never actually occurred. They just were brought into the mind when they're in a vulnerable state of hypnosis, if you will. So it's definitely an interesting topic, and I hope your brains are churning and you're remembering memories and you're thinking about this process and maybe inspired to learn a little bit more. So great discussion so far. One thing I'm going to bring up is next week is spring break. I'll just let you know that one of my passions is really science communication and using media to tell stories about research or really what's going on in our sort of scientific community. So last year I filmed a documentary about an event that is related to this topic of usability, which really comes up in sort of the human factors psychology field. Basically, usability has to do with how a product is used by you, if it's easy to use based off of the way it's designed, if it's difficult to use, all based on like psychological principles, how they're applied in these sort of products. So it's kind of fun, and I'm looking for help in transcribing interviews. So if you want to have this sort of different extracurricular experience on your resume, feel free to contact me. The final product will hopefully be submitted to South by Southwest. Has a big technology sort of side by it, so or another film festival, etc. There are a couple other people working on it with me, and a possible line in your resume might read like you assisted in post-production of a documentary about usability. You transcribed professional and confessional interviews for an independent documentary, that kind of thing. So if anybody's looking for that, you help me out, but yeah, decide what you want to do. Okay, so we are going to start discussing chapter 6. I don't think we'll finish today. We definitely won't finish today, but this is the topic, long-term memory. So long-term memory is basically an archive of information about past events. It's also an archive of our knowledge, our actual facts that are stored in our brain for a long time. And it contains information from about 30 seconds or to a minute. So anything past that short-term memory, stretching back to as far back as you can remember, that first memory that you really had. So think about it, you can see sort of a timeline or a range of these memories. So going from the farthest back you can remember, a lot of us are going to remember our elementary schools, then when you started college. This guy went to a football game last week, so yesterday he shopped for clothes. He was walking to class 5 minutes ago. So you can really see the largeness of the range of those types of memories. So it's everything that you can recall that's beyond that short-term memory capacity. So contains information from about 30 seconds to a minute ago all the way to your first memory. It stores information at different levels of detail we'll go through. And it interacts with short-term memory on current tasks so that you're able to better perform that task and even store information from that task into your long-term memory. And it provides background knowledge for our working memory to assist in those processes. Here's a quick example discussed in your book. So
Tony is speaking with Cindy. Cindy tells Tony, Jim and I saw the new James Bond movie together. So then Tony has in his short-term memory this concept, she went to the movies with Jim. So the interplay with his long-term memory is that he knows that Jim is the guy Cindy met 3 weeks ago. She told him about that, supposedly, or assumingly. That James Bond is 007. He knows that, his recollection of that character. He saw the movie and he had some good opinion, or had good explosions within the movie. Cindy is a big James Bond fan, and from the way that he understands relationships, it seems as though they like each other. Maybe they like each other, that they went to a movie together. But you can really see that sort of interplay, that short message that immediately comes into his mind once he's heard Cindy say that she went to the James Bond movie with Jim. That has that interplay with the long-term memory to really understand the total concept of what happened, and then convert that final understanding into the long-term memory, or even have things to say immediately about that. For instance, hey Cindy, do you like Jim? Something like that. So there was a study, this is an interesting study talked about in your book, so 1962, a while ago. So it illustrates sort of this distinction between our short-term memory and our long-term memory. So in this experiment, participants were read this list of 15 words, and then after the sequence was presented to them, I think there was a 3-second delay in between each word's presentation, so verbally. And then after the experiment, they were told to write down as many words as they can remember. Keep in mind that these were presented to them in a list, as in number 1 was barricade, number 12 was muffler, that kind of thing. So you know what order these words are presented, and then they are just supposed to randomly recall anything that they did remember. So this graph is what occurred when you analyze that data. So given the bottom is that serial position, so in the series, number 1 to number 15, I think it was, or maybe this list. So this list only has 15, in the experiment they had 20, or this version, whatever. So you can see there's an initial level which declines towards the middle and then raises at the end. So they have the percentage of words that were remembered was more accurate in the beginning, less accurate in the middle, and more accurate at the end. Which is an interesting phenomenon, right? You would expect that maybe it'd be linear, or even just a straight line. You remember randomly all of the different things that were presented to you, but it turns out you have this kind of dip in the middle. So think about that a little bit. So recall that short-term memory only lasts for about 30, 20 seconds, that sort of range, so less than a minute. And anything beyond that is going to be long-term memory, if you're remembering it. So the idea is this primacy effect is that beginning part, that initial position into the dip is the primacy. And it illustrates sort of this long-term memory effect. So when you're presented with these words over and over in that list, within that 3-second period, you're able to kind of rehearse them to yourself. You're trying to keep them in your memory, remember those words. So the distance between the beginning and the end, you have brought those words into your long-term memory. You're able to do so because you're not overwhelmed at that point. And then the very end of the experiment, when you get the increase, is the effect of these things are still in your short-term memory. You haven't forgotten them just yet. And the way to prove that, they had an experiment where just 30 seconds after the whole presentation of the sequence, they just waited 30 seconds before telling them to recall as many facts as they were able to recall. And then that effect went away, that rise at the end. So that shows you sort of the effect of long-term memory versus short-term memory. So once that short-term memory drops away, everything you're left with is long-term memory. So just to recap, the primacy effect, better memory for words at the beginning of the serial curve because you have more time to rehearse them and you're not interrupted or interfered with all the other information. So the words are rehearsed during the presentation of the list, so they get into your long-term memory. How can this be changed? To increase, present the list more slowly so that there is more time for rehearsal in between those, the presentation of the words. So instead of giving you a 3-second delay, I tell you a word and give you a 5-second delay. You have a little bit more time to keep that in mind to convert it into your long-term memory. So that would correlate with an increase in that percentage accurately remembered. And then that recency effect is that increase at the very end. So better memory for words at the end of the serial position curve. These words are still within your long-term memory. It can be changed, but you can have it decrease by waiting 30 seconds, so waiting that capacity of short-term memory, so all the things within that short-term memory drop off, and you're just left with the initial decline and then the straight line about remembering. So if you'll remember studying it a little bit more, memory, distinctions between short-term and long-term, are they similar? Are they different? We talked a little bit, I think even in chapter 1, the double dissociation Bayesian studies. So you basically study people who have brain damage and you know where their brain is damaged. So that helps you kind of figure out what processes are affected and how that relates to that brain damaged area. So we have Clyde Waring, I think we discussed last week even, a man who had encephalitis, so his brain swelled up and he could no longer make long-term memories, so his constant life was living in the last 30 seconds of his experience. He wasn't able to recall things that happened beyond that, so it was like that constant state of waking, or he said it was like death. Terrible, not very fun. Also HM, who was a patient who had, I think it was the hippocampus, yeah. He had his hippocampus removed because he had seizure issues. The result was, again, that he lost his ability to create long-term memories or access them, but his short-term memory was okay. He could remember within that 30 seconds. And then you have another patient, KF, I think it's a she, had damage to prefrontal areas. So that's, that position in your brain. And so the short-term memory ability was impaired. She could only remember like a couple of things. Remember that capacity of short-term memory is about 5 plus or minus 2. That was very much diminished in this patient. So, and other examples discussed in your book, shows you that that prefrontal area is related to short-term memory, although she was able to still access and store things within long-term memory. So it gives you some idea that these are related processes, but they occur in different areas of the brain, or they have different associations with different areas in the brain. So here's an experiment so this is semantic coding, that's what it's studying. So remember, semantic is sort of the meaning of words. So in this experiment, this passage was read aloud. There's an interesting story about the telescope, etc., etc., to participants. And then the next step was giving them this short list of examples. So what specific sentence was unchanged from the passage that you read? He sent a letter about it to Galileo, the great Italian scientist. Galileo, the great Italian scientist, sent him a letter about it. A letter about it was sent to Galileo, the great Italian scientist. He sent Galileo, the great Italian scientist, a letter about it. So as you can see, they're all very similar. But in number 2, the meaning is totally changed, right? So Galileo sent the letter instead of somebody sending a letter to Galileo. So participants were able to say that number 1 was unchanged from the passage. Number 2 was changed, so the meaning of that is very different. But a good amount of people mistakenly saw or thought that number 3 or number 4 were also unchanged from the passage, so literally said to them. And this gives you evidence that that storing process, so whatever is brought into your long-term memory, you're better at it for the meaning. So in number 2, the only thing that's really different besides the literal translation is the meaning of it. And your mind is able to pick out the meaning, but not necessarily the literal order of these sequences, so not necessarily the auditory, not necessarily the visual, but that semantic representation of that information. So there are 2 types of long-term memory that we'll really talk about. So there's declarative memory, which is really your conscious memory. So you're aware of this type of memory. And then there's your implicit memory, which you're not consciously aware of, but you still have. You still have that capacity of long-term memory. So in declarative, you have that episodic memory. Well, we kind of talked about that reliving of events. You remember how it happened. You kind of even can put yourself in that situation again. Or we have this semantic memory, just that fact, that knowledge about the situation. In implicit, we have repetition priming we'll go through, and procedural memory we'll go through. Those are a little less, they're not conscious. They're a little harder concepts to grasp, but very cool. And so in your declarative memory, your episodic memory is for these personal experiences in your life, or even remembering series of events, even if you watch a movie. It's remembering how the events played out. It's kind of like going back in time and reliving these things. Versus semantic memory is really just that information, like you're at a bar trivia night and you can remember certain facts about things. That's really that information, that semantic meaning that's stored. So these are both present and they're very different. So there's distinction that can be observed based off of those types of information. So again, think of episodic memory as your mental time travel. So you can really put yourself back into the shoes that you had when you were that young, and you travel back in time to reconnect the events in your mind, kind of going through that process again. It's also self-knowledge, so remembering that involves that mental time travel. And semantic would be accessing knowledge about the world. So the knowledge that is not tied to specific personal experiences, although it can be. So it would include things like facts, vocabulary, numbers, different concepts, etc. Is really associated with knowing. So you know all of the concepts of cognitive psychology. You're able to say that on an exam. Not necessarily, I remember coming to class every day. I remember discussing what memory is to me. And here's just a little table recapping that information. So the differences within that episodic and semantic memory can be studied again in the double dissociation lesion study. So this patient, Casey, had severe damage to the hippocampus after a motorcycle accident. He lost that episodic memory. He wasn't able to mentally time travel, put himself back into those shoes and remember really the sequence of events. So he can no longer relive these past experiences. An example would really be that he knows that his brother is dead, but he can't remember the circumstances that led to the death, or he can't remember the circumstances of when he found out or going to the funeral, anything like that. He just knows the fact that his brother died. So that factual understanding is not compromised, but the reliving of those memories is. And then in comparison, here's a woman with brain damage after encephalitis. So again, like swelling, I think it's typically water in the brain. I don't know, I'm not a physiology person necessarily, but this was an Italian woman who suffered this event, and she was hospitalized for a little while. When she finally was allowed to go home, she had difficulty, she started noticing difficulty recognizing people who were familiar to her, so knowing those individuals. She could go to the grocery store, but she had a really hard time remembering what's on a shopping list, so those items that she was supposed to purchase. She couldn't recall facts that were, very, that should be very easy to recall. For instance, Italy's involvement in World War II, it would have definitely affected her and everybody around her, but she was unable to remember that it even occurred. So these facts were really compromised because of that damage. But still her episodic memory remained intact. So it really shows you about the distinct brain areas within those regions. So again, just recapping, KC had damage that left his semantic memory intact, but his episodic memory was shot. And this Italian woman discussed in your book had poor semantic memory, but her episodic memory was intact. So brain imaging is super fun, super cool, complicated, but worthwhile. And it's given us a little bit more light into what brain regions, bless you, were associated with these two separate functions within declarative memory. So in brain imaging studies involving episodic memory, you could have somebody remember a sequence of events. Really, you get sort of that prefrontal area. All the kind of blue is what you should be looking at basically in this image. It's hard to read, but you can take a look at the slides. So remember kind of that prefrontal stuff. And then in the next page, you'll see sort of that procedural. So there's semantic, procedural, and working memory. Those are sort of areas that are more involved in this semantic memory. So, I mean, the takeaway is that they overlap each other, but by doing these fancy studies and even comparing people with different types of damage, we can see that even though they're related, they are distinct from each other. So you can really say that there are two types, that episodic and that semantic. So here's another illustration of kind of how they relate to each other. Episodic information can get lost, but you can still remember the facts. So in the book, it sort of discusses if you live long enough, if you have whatever on your mind, as you go on with your life, you might forget that episodic series of events. For instance, when you graduated high school, you might at some point forget the day that you graduated, the whatever you pulled the senior prank, that type of thing. You might forget that sequence of events, that overall feeling that you had, but you can still remember that you graduated high school in 2000 whatever, and that it happened on this day, that kind of thing. So you might still remember the facts of something that happened in a sequence for you, but not remember the actual mental reliving of those events. Semantic memory can also be enhanced by episodic memory, so sort of indicating again that there's a connection between the two. So facts about important events are remembered better. So for you, you probably all remember where you were September 11th, that type of thing. It was very, it's going to stick out in your mind probably for a long time in that episodic way, and it'll help you remember the facts sort of that situation. So semantic memory can also influence our episodic memory, in that the knowledge about the facts can bias your recall about the events. You can kind of look in your book. I don't have an example off the top of my head for that, but remembering facts can make you remember the episode as well. So implicit memory is that sort of other side of our long-term memory. So the implicit memory is something that's not, you're not consciously aware of. You're not going to be able to tell me consciously of your memory for priming or procedures, but you still have it. And there's experimental evidence to indicate that you have it. So implicit memory is previous experience that improves or even hinders your performance on a task. Its experience is not conscious. The experience is not consciously remembered by you, even though part of your unconscious mind still has a recollection of these things. And the memory is non-knowing, you could say. So you don't have these facts that you could verbalize to somebody. It's something stored within your mind, and I'll go through some examples of how that works. So you have repetition priming is one side of things. So your performance in response to a stimulus is changed if the stimulus has been encountered recently. And then how it affects procedural memory, or this procedural memory, memory for how to do things. That could be including muscle memory, how to ride a bike, how to play the drums, that type of thing. So you remember in your body how to do these procedures, or how you were positioned when you learned these things initially, but you're not going to be kind of consciously talking about that type of thing. Kind of keep that in mind. Little loftier than that, but take a look at your book, read about it. It's worthwhile to understand. So repetition priming, there was an experiment where participants were presented with a list of, I think, 96 words. And then they were asked to complete these partial words in that experiment. So the example is cabaret, and then you would test them if they remembered that thing by presenting them with C space space A R space T. So people, so filling in the spaces was more successful in conditions when the priming stimulus was presented compared to the new words, even though they weren't exactly great at telling you the ones that they remembered. Their performance was still enhanced just because they were exposed to the words before. Another experiment, this I believe is with patients who had, or no, I'm sorry, that's the next slide. So yes, in that previous study, if you take a look at this graph, their conscious remembering, they can tell you that they recognize the words, decreased, as you would imagine, between 1 hour and 7 days. So over time, they're forgetting these words, but their ability to complete the words that was enhanced by seeing the words again, that was unaffected within that 7-day period of time. So they can't consciously tell you that they are remembering these things, but they are in some way remembering them, as you can see by their performance boost. Here's another experiment of this repetition priming. So this was the experiment where they have patients with amnesia. Always that fun pop science thing, amnesia. So they were presented with stimuli that were ambiguous and then got more, were elaborated on further throughout the trial. So this is an airplane. In the first image, it's very difficult to figure out what you're actually being shown, and then it keeps progressing until the participant tells you, oh, I know that's an airplane. So maybe it gets to probably D or something like that. Maybe in A, B, and C, it's still a little too ambiguous to call, etc. But at some point, they're able to remember it. So the people, so this is the error score on the y-axis and the days of training. The participants weren't able to consciously remember seeing the stimuli, but their error rate went down. That is, they were presented with these things, so they were trained on them. As that continued over the 3 days, they still weren't experiencing, or they got better at the task without being consciously aware of the fact that they got better. I'm trying to remember how many pages we're going to go through. So your procedural memory is memory that is about okay. Your procedural memory is memory about how you do things. So it's that sort of muscle memory or your unconscious remembering of how to get home, that kind of thing. So experience is procedural memory is your experience, how skill was acquired and not remembered, and it remains intact even if your episodic memory is lost. So these examples: riding your bike, tying your shoes, reading a sentence, playing a musical instrument. You might not remember consciously the sequence of these events, and it's not something that you can consciously call out what it's like to ride a bike, but you still remember, your body still remembers how to achieve these things. So this idea of the propaganda effect is kind of interesting in that procedural side of things. So participants were asked to scan an article that contained ads. They were not asked to pay any attention to ads, so it's just free, like take a look at this thing. Later, they were asked to rate a bunch of different ads as appealing or not appealing. So the ads that had previously been presented to people were rated higher than the other ads as more appealing. Even though the participants were not able to say that they explicitly remembered what was going on in any of these ads, they still rated them higher, which kind of gives you this idea that something weird is happening here, that your likability is improving even though you're not consciously remembering being exposed to these things. So we call it a mere exposure effect, and it's interesting because it's a bias that you may not be aware of this thing, and it's still affecting the performance. So things like actually seeing advertisements in television, etc. The product placement sort of effect, like you see somebody like carrying a Coke bottle in a film, whatever. You might not be consciously aware of these things, but they do have an effect on your behavior, so you're buying things that you might not necessarily want to buy just because you saw it before. So it's sort of that mind control stuff that you might want to be aware of. It's interesting. Talk a little bit about encoding, and actually there's not much that we needed to go through, so I think I'm going to play the John Oliver video just because it's cool. So encoding, so we've talked about this code, so the different versions of that memory, the semantic memory, the verbal recall, the visual recall, that type of thing. That's sort of some books, I guess, it's talked a little bit about in our book. Some things use the words encoding and coding as, why can't I remember the word? They use them interchangeably with each other, so they can say coding or encoding and it means the same thing. But for our purposes, we say that coding is that different modes of kind of information, and encoding is acquiring information from the environment and then transferring that into your long-term memory. So it's the process of storing that information in your long-term memory. Coding refers to the form of information that's presented. Encoding goes hand in hand with retrieval of information, and retrieval is the process of transferring info back into short-term memory. So it's sort of, look at the bottom, you've got that diagram. Short-term memory is encoded into long-term memory. Information from long-term memory is retrieved and brought back to short-term memory. So there are two types of rehearsal that are really discussed or really important within how we are keeping information in our short-term memory. So remember, you can say something over and over to yourself, keeping it in your short-term memory. But you can talk about maintenance rehearsal, so helps you maintain information in your working memory and is not effective way of transferring memory into your long-term memory. And then elaborative rehearsal is when you're thinking about the meaning of an item, so not just the facts about the item itself. We'll go through an example. So when you're making connections between this item that you're presented to and your previous knowledge, it helps you encode something and actually remember it longer, bring it into your long-term memory. So the idea can be illustrated in this experiment, this levels of processing. So basically that there's different amounts of complexity when you're thinking about the information that you are storing in your short-term or your working memory. So what's you're consciously thinking of, if you're thinking about it in a couple different ways, it will affect how well you're able to code it into your long-term memory and remember it forever. So I think it's kind of interesting for your studying habits, for instance. So memory is better when meaningful connections are made, so not just the appearance of the word, how many vowels it has in it, but the actual meaning of the word itself, what it connects to within what's shown in your long-term memory. Meaningful means connection to knowledge in memory. For instance, if I say cereal to you, maybe you don't necessarily think of the idea of the process of presenting within a series of information. Maybe you'll think about this. Who's had this experience? You start to, I guess, as you get older, etc., you think about the meaning of words and the roots of these words and how they relate to other things. So series and serial, inform, information, that type of thing. So they mean different things, the definition of the words, but the way that they're related to each other helps you sort of understand, get a better understanding of these words. So like different Latin roots or different things. It's kind of fun. You might do it eventually. But that's kind of the process of making something more meaningful. Like if you're learning vocabulary, for instance, learning, I think a lot of people doing medical stuff, you have to learn Latin roots to a lot of things just because a lot of conditions are classified by these. Like for instance, itis means swelling. So encephalitis means swelling of encephal, but basically keeping those parts of information, relating those to something that's more meaningful will help you remember it. It's kind of this idea, this was proposed, that your memory depends on the depth of processing. So shallow processing would be that little attention is paid to that meaning, so you're focusing on the physical features of whatever you're paying attention to. In this experiment, it was a passage, and you would think of each of these words as in how many vowels do they have in them, or you could think, how many letters does it have in it, versus this deep processing, so you're paying attention to the meaning of these words, and this helps you elaborate. It makes you better connections to the word itself, which enhances your encoding ability. So here's an experiment to sort of illustrate. There were 3 levels that were presented: the shallow, deeper, and deepest. So in the shallow portion, a question about physical features of the word was presented. So question, is this word printed in capital letters? Bird. So here it's lowercase, so you just say no. In 2, it's a little bit deeper, so a question about rhyming is presented. So does the word that you're about to be presented with rhyme with train? The word is pain, so you'd say yes. And then in the deepest processing, it's fill in the blank for this question. Does the word fit into this sentence? He saw a blank on the street, car. In this case, you'd say yes. It makes sense within that sentence, so you'd say yes. You can kind of see this illustration of that depth idea. So in the first case, you're not really paying attention to the word itself, just the physical features of what's being presented to you. In the second, you're paying attention to the oral presentation of that information, how it relates to train. So it's a little deeper than just your visual side of things. It's a little easier to remember. And then in the third part, you are seeing the presentation within a context of something that's meaningful. And then the results were, that your percentage of accurately remembered is increased by that sort of depth So that supported this theory, but it also had criticisms. There's not really a lot of, I guess, experimental control when you're just saying something is more, is deeper than another thing. It's just sort of postulated. It's hard to study that or keep that as a real viable hypothesis. So here was another study that was similar, but also getting at sort of the criticisms of this depth of learning. So again, looking at the relationship between encoding and retrieval. So two types of tasks. There was a meaning task and a rhyming task. And so it's the way that you're learning this information. So in the meaning task, participants heard that fill in the blank that from before. So what is it? So following the sentence, participants heard the target and they had to say yes or no. So the blank rode the bicycle, followed by the word boy. You say yes. In the rhyming part, you hear, for example, for the sentence, blank rhymes with toy, and then you hear boy and you say yes. So again, it's very similar to that previous experiment with that depth idea. So you're thinking about the meaning versus you're thinking about the rhyming. And again, they were able to replicate that if you are paying attention to the meaning, your performance is increased. Although a second experiment, you encoded the information the same way. So you had the meaning task and you had the rhyming task, but instead of asking them, did you hear this word before? They would say, did you hear anything that rhymed with X? So boy, let's see. So boy rhymes with toy. Instead of did you ever hear boy, they would say, did you ever hear something that rhymed with toy? And in that case, the rhyming people performed better. So it shows you that it's not necessarily all about this depth of learning. There are other things that are interacting. And that's where we will stop on this for today. But I'm going to play that John Oliver video.